let's move on to inheritance and polymorphism in object-oriented programming. So let's first start with inheritance. So let's say we have a class for students, class student, and let's say we have a class for professors. So class student, let's write a simple constructor. If not name base value missing name, then self dot name is equals to name self dot house is equals to house. So this is a class student, and let's say so a professor also has a name, but we have subject he teaches, which is different in this class. So let's take this simple example. Like we have a class student, we have a class professor. And what we can see is that there's some repeated code here, right? Let me highlight this part. Of course, this is a very simple example, but you can imagine that in a very large program, there will be a lot of repeated code, not just 3 lines. So Python provides a way to structure code and reduce its repetition by arranging class in a hierarchy. So how will we do that? So let's say we have a third class called person, because student and professor both are person. And we can actually say that, okay, person has the attribute name. So let's define our so we have a person class here. So there's a way for inheritance to work, because we have this part as a part of person. We can remove this. Similarly, we can remove this. Now, how does Python allow to take all the properties or definitions of this class person into students? So how do we inherit? We just write the class name when defining the student class. So what it means, the class student inherits everything from person as per the definition of person. Similarly, class professor inherits from person. Okay, this is good. Now, this is not enough, because we have inherited from person, but we also want to use these things, which is part of person, right? And of course, we can see in these classes that name has not been used to initialize the state. So what can we do? So there's a function super, which says that we will go to the super class and we'll call the method init and pass the parameter which is needed for instantiating the class person, right? So this is it. Similarly, we can do the same for professor. So what have we done? We have created a class person which has an object attribute name, and we have created a class student which inherits from the class person, and we have a class professor which inherits from class person. And in order to instantiate the name attribute, right, we are using the construction of the parent class, which is using super. So let's see, we have defined it, let's use it. So let's say we have a student object of type student, and we have name Dev, and we have a house blue. Similarly, we have a professor with small p of class professor. He also has a name. Let's say J as initials for my advisor, and the subject he teaches is computer vision. And let's say we print student, we print professor, and let's run it. So it just prints the object where it is located with the address. And of course, as we have seen before, if we wanted to print it nicely, we have to define a function, the magic method called stir, dunder stir dunder, and we can return an f string which says self dot name from self dot house. Similarly, if you wanted to define something similar for the class professor, we can do that. But instead of self dot house, we need self dot subject. Let's see it in action. We clear the screen, we run it again, and see it prints us nicely. What have we learned in inheritance, right? We can arrange classes in a hierarchy so that repeated code is reduced. That's one way to look at inheritance. So here what we have done is we have used this super, right? But sometimes what happens is we want very simple way to choose which constructor to use. For example, we might want to, instead of using super, we want to use, let's say, person, because we might have multiple classes from which we are inheriting. Similarly, here we can choose it, person, and nothing should change. It is just that instead of abstraction super, we are specifically choosing that we want to use the constructor of person and pass in the name. And we can actually, if we had one more class called maybe students address or something like that. So we can inherit from multiple classes by using comma, right? I'm not doing that, but I'm just giving an example that we can inherit from multiple classes. So what we have just done is, instead of using super, we are using the class name and using the class whose constructor we want to use, right? That is what we have done. That's the only change. Let's run it, and we see an error that we are missing one argument. So what's happening here is we are kind of accessing person class by the name of the class and directly accessing the function. So since we are accessing the function not via object but via class name, you have to pass both arguments, self as well. So that's the issue here. So now it should work. Let's see. Let's clear, run, and it works, right? So this is inheritance. Let's look at one more super simple example to show you something. Let's clear this all up. So let's like super quickly have very simple classes. Let's say I have a class swim, def swim, self, print, swimming, and class fly, def fly, self, print, flying, And let's say I have a third class called duck, and here we are inheriting swim and fly. So in this example, we are inheriting two classes and we just pass. So what is happening is basically swim class has a method called swim, fly class has a method called fly. Duck is something which can swim and fly, so these properties can be useful for duck. So we inherit it. Let's use these classes. So duck is equals to duck dot swim. It should work. Duck dot fly. This should also work. Let's see it in action. Clear the screen, run it again, and we get swimming and flying, right? Now there's something, so whenever we have multiple classes, there is a specific order in which methods are searched for in the class hierarchy. So let's print that first. Print duck dot MRO. MRO is method resolution order. Let's run it and print it and see. So what is the order in which methods are resolved? First, it looks at the class duck, then it's look at the class swim, then it looks at the class fly. In that order, it will search. And by default, object class is always there. So this is a method resolution order. So this is kind of all about inheritance. Now let's look at something super interesting. Let's look at operator overloading. The first thing is that this is not the first time we are looking at operator overloading. When we were doing 1 plus 2, plus was adding two numbers, but we are using the same plus sign to concatenate two strings, right? So let's run this first and talk more about it. So what is happening is this plus operator has been overloaded in this example, right? It looks at the left hand side type, right hand side type, and then does its action. Similarly, hello world, left hand side is a string, right hand side is a string, so it's now it has to concatenate and return a string which is a concatenation of both. There's one more interesting one, right? Let's say hello into 3. So in this case, this multiplication operator, there's a on left hand side there's a string, on right hand side there's a 3, and it kind of understand what it has to do. Hello, 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 because we did into 3. And of course, we can do 1 into 2 and so on. So this is what operator overloading is. But why are we talking about it now, right? We're talking about it now is because we just learned how to define our custom data types via classes. And we just want to see that if I just wanted to add two objects and make it behave in a certain way, how we could do it. So let's start with creating a class called vault. It is exactly what it means. Let's define the constructor. Self is always the first argument in the constructor. In the vault, we could have gold coins, which by default is 0. We could have silver, or we could have bronze coins. So this is our constructor. Let's say I wanted to just print nicely. I just return an f string self dot gold, gold, self dot silver, silver, and self dot bronze, bronze, right? So this is a simple vault class. Let's create a vault. Let's say I want to create a vault for myself. Let's call it div is equals to vault. And let's say I have 80 gold coins, 30 silver coins, 10 bronze coin. Let's say I want to print div. Okay. Okay. The semicolon missing. Now it's fixed. And see, when you print the object, it prints I have 80 gold coins, 30 silver coins, 10 bronze coins. Now let's say there's a vault for the husband in the family. There's a vault for wife. Let's say the numbers are different. Let's say it's 50, 10, 5, and you could just print husband and print wife. Let's do this first and see. Till now everything looks fine. Now suppose I wanted to add the vault of husband and wife. Let's call it family, and I just want to add husband plus wife, then print the vault for family. And what is the expectation? The expectation is that in the family vault there would be 8 plus 80 plus 50 gold coins, 30 plus 10 silver coins, and 10 plus 5 bronze coin, right? Let's see if it works. See, it doesn't work. What? There's a type error. It says that the operand plus for the type vault and vault plus vault type is not defined or not supported. So basically, I wanted to overload the plus operator. Like how to do it in Python? There is again a magic method called add, and it takes two arguments. The left hand side argument, which is self, and the convention is the right hand side argument is other, and we need to basically add these. So first is gold is equals to self dot gold plus other dot gold. Silver is equals to self dot silver plus other dot silver. Bronze equals to self dot bronze plus other dot bronze. Then we return vault of gold, silver, bronze. So what are we doing, right? Basically, when this plus operand of which basically when we do a vault plus vault type, right? So this operand is expecting a left hand side and a right hand side, and both of them are of vault type. So if you look at this add function, this is the left hand side, this is the right hand side, and both of them are vault type object. So we can basically do something with those things, whatever it could be. It might be anything. But in this example, we are just adding the gold coins together, silver coins together, and bronze coins together, and creating a new vault type with these values. And basically adding two vault type should return a vault type. And let's see this in action now. This time it should work, and it definitely works. The first one is the vault of husband. The second one is vault of wife. The third one is the family vault, which is basically the sum. 80 plus 50 is 130, 30 plus 10 is 40, 10 plus 5 is 15. So basically the family has 130 gold coins, 40 silver coins, and 15 bronze coins. So this is operator overloading. Next, I wanted to talk about polymorphism. So again, let's clear it up. Let's say I have two classes. Let's say first class is India. It has three functions: def, capital, self is always there as the first argument. We print the capital. Capital is New Delhi. Similarly, we have language. First argument is always self. We print. Of course, there's not one languages in India. Even official languages, there are many official languages. But for the sake of demonstration, we'll just write Hindi is one of the widely spoken language in India. Then we have the type of the country. We'll print, let's say, developing country. Okay. So we can see that we created a class. We also remove this, which has three methods: capital, language, and type. Let's create another class. Let's say USA. The capital is not New Delhi, so let's modify that. Capital is Washington, DC. Language is undoubtedly English because that is the major one. The type will be developed country, right? So what we can see that there are two classes with exactly the same functions, right? Let's see it in action. So we have the first object for India, and we have second object. Now actually what we can do is for country in India and US, we can write country dot capital, country dot language. We can have country dot type, right? Since both the type of classes and their object will have methods capital, language, and type, it should work. Let's see it in action. And when I expand the terminal, it definitely works. The first three lines is for India, capital is New Delhi, Hindi is the widely spoken language, it's a developing country. For Washington, capital is Washington. For USA, capital is Washington DC, language is English, it's a developed country. So what have we seen here, right? We have two classes which have the same methods. So even when the data type is different and methods are the same, we can easily use it in a certain way. For example, we are looping through different types of classes or different types of data type, the same for loop, right? And this is polymorphism in a way, that it behaves in a similar way because we can call the same functions for different data types. Let's slightly extend it. Let's say we defined a function. Let's have the argument obj, and we can just call these three things. In fact, what can we do is just copy this into the function. Yeah. So another example of polymorphism is I can just use a particular function with different data types, and these are custom data types. So we are kind of looking at polymorphism in action. So let's clear the screen. Let's run it. and see, it returns the same thing. And this is what polymorphism really is, that different data types have the same methods, and that's how polymorphism works. Let's look at another example of polymorphism. Let's say I have three kinds of files: audio file, video file, and image file. And all three files could have, let's say, a method called play for playing the audio file, for playing the video file, or displaying the image file, right? And now it's obvious that polymorphism can come into the play because all of these three things are just media files and the method is play. And let's quickly just look at it. So let's say we have classes, all three are media files. And let's say audio file inherits from media file because it's a type of media file. So this is my audio file. And because video file and image file will have very similar structure, I'll just copy it twice. Video file. Right. Now what we can do is you can see polymorphism in action. You could create an object for video file, you can create an object for audio file, and we can create an object for image file. And because of polymorphism, all these three classes have the method play. I could say for media file in media files, media file dot play. Let's run it. Hopefully there are no errors. Let's clear the screen, run this, and see. We had a list of three objects, all of different data types, but because of polymorphism, we can observe that all three of them have the method play. So we can just loop it. Each value in this list is just an object of different data type, and still it successfully runs, right? So this is another example of polymorphism. And this is all about object-oriented programming. Next, let me clear this up. Let's just look at generators, custom generators and iterators. Let's look at iterators and generators with yield keyword. Okay. So, okay, let's do that in the next video.